Hey everybody, this is Larry. This is day 16 of the LeetCode Daily Challenge. Hit the like button, the subscribe button, join me in Discord. Let me know what you think about today's problem. And today's problem seems to be the third iteration of the best time to buy and sell stock. What is the what is the variation on this problem? Let's see. So find the maximum profit you achieve. You can do only 2 transactions. Okay. Um. Okay. So n is 10 to the 5th. So that's the part that's a little bit different. I think. I mean, obviously it has been yesterday, so it's not like I didn't forget what happened yesterday. So you can use that for yesterday for k is equal to 2, maybe. Yeah, I mean, I think that would be good. I do know that someone did use. I have to think about how to think about it, but yeah, I don't remember all the variations and all the answers to variations of them because I don't really find it useful to kind of remember them. And if I do remember them for whatever reason, it's mostly coincidental. Like I'm not, I'm not studying at home trying to think about whatever it is. So yeah, so I think what we had yesterday was reasonable. So I'm just trying to think about how to talk about the solution. To be frank, and usually I mean, I think very often I will just start from scratch, if you will, and kind of do the explanation from assuming that you don't know any, assuming that you don't need to know anything. But that said, the video is from yesterday, and this month is kind of full of these things where it seems like where yesterday's solution or yesterday's problem is way related to this one. So I'm not going to go into it that much. I am going to recommend that if you do have trouble with this one, start with my video yesterday, and then we'll kind of play around with it. I'm not going to copy and paste, at least not. Yeah, I'm not going to copy and paste because that's not what I do in general. I mean, I will do it once in a while, but it has to be whatever. Like I have to be lazy, I guess, really lazy, or it has to be really long, or there's some like weirdness about it. I'm not going to copy and paste per se, but I am going to. I'm going to type it out, and I'm not going to explain it too much, or because I'm just going to refer to the the point where we have, roughly speaking, yesterday's code. But for me, this is going to be practice of me trying to do it from scratch, even though I did do it yesterday, so I don't know. But also, if you feel like this is a little bit slow, then just fast forward or skip ahead until I finish typing it out. I am solving these live, or as live as I can be, because this is from yesterday's problem, or a variation of it, so we'll kind of play around that. So let's get started. Yeah, let's get started. So yesterday's solution, we have something like, okay, buy. So on ith day, we are in a state where we can consider buying. What is the max profit? And then, of course, I think we set something like this is equal to n. Let's just set n is equal to length of prices. If I is greater than n, then we return 0. Otherwise, we have two things, right? Max profit buying, and the cost of that is go negative prices of I plus sell of I plus 1. Max profit not buying. That means that we can. Oh yeah, I was just double checking whether you can do multiple transactions simultaneously, though I guess that doesn't really make sense. Otherwise, you just do the maximum twice. So, I mean, it makes sense. It's just that it would not necessarily make sense as a problem. But yeah. So you have something like this. So then sell, same thing. Maybe I should have copy and paste it. We're in a state where we can consider selling. What's the max price? We own the stock currently. So yeah, so I is equal to n, we return 0. Otherwise, max profit selling. Then we get the price at this thing plus buy of I. Oh, I was gonna say I plus 2 because yesterday's was the one with cooldown. Maybe they need a cooldown, but I guess there's no cooldown. Then we can just buy sell it, or after we sold it, we can buy the next day. So this is the key difference here. If you are following from yesterday. Not profit not selling is good, so then we sell the next day instead. So we return max profit selling and max profit not selling. And then here we can return buy of 0. Right? So this is the general solution that we had from yesterday. I didn't add the memorization quite yet, but let's kind of run the code to kind of see. I mean, it shouldn't work because we do more than one transaction, right? So yeah. But I just want to make sure that it runs without any random it's not really compiler error. I know it's Python, but like, you know, any kind of typo related errors. So yeah, so okay, so now let's add in. So these are kind of things. Again, we haven't done the memorization yet. So then the question is, okay, now what is the difference between this one and what we have here, right? Well, here we can perform at most 2 transactions. So then what I would think about is, okay, let's say K is equal to 2, which is the number of transactions. Then can we make that a dimension of the state? And in this case, the answer is yes, because we talked about the complexity yesterday. So again, if you have any questions about it, refer to yesterday's video. And if that doesn't address it, you know, come and ask me more questions, either here in the comments or in the Discord. But yeah, so this is going to be linear time, and this is linear time, right? And then here we ask, can we confer another state? And then here we have K. What is the K? What does K do, right? While we can make K more purchases or transactions, I guess. Complete, and I'm going to put that here. And what is the variation on this, right? What does that change our state? We go, okay, once we buy, well, what's the max profit buying, right? Well, that means that we bought and then we still use K, because we still have K more transaction. I mean, I think you can do. That's the way that's my convention. I think depending on how you want to phrase it. You can make it K-1 here as well. And what I mean by that is you can, the correct solution is basically you needing to have your states be consistent. So as long as you're consistent with how you define things, that should be okay. And what I mean by that is that, for example, a variation of how you can define this, though that's not what I'm doing, is, for example, you can be, okay, we can buy K more times. If you could buy K more times, then well, this is K-1 because now you used one of your buys, right? But for me, I'm saying I could complete K more transaction, and a transaction is complete when you sell. So I'm gonna make the change at the sell portion. So that's kind of my caveat here. So in both cases, this is takes K, and here, well, here we actually use a transaction as we mentioned. So the K here refers to the transaction after we sell, and then here. If we don't, then we can keep doing. Yeah, if I is equal to n is equal to 0. Otherwise, if K, and we how do we want to phrase this? So now we have to add some conditions to make sure that K is positive. Yeah. So here it seems like K will always be positive, so we don't have to add anything. You can always add more constraints just to, if you want to kind of just in case, I suppose. But in this case, you can actually show that it cannot be or K cannot be negative because there's, you know, because assuming that all inputs to here are valid, meaning that K is between 0 to 2 in this particular case, then this will also be between 0 to 2, right? Where in this case, these inputs may have to be validated because K can be greater than K can be less than 0. So we can check there. We return 0, right? And actually that's not true. this is a so that's where you have to be careful, because sometimes you get into things where I say the wrong things. Because we may think about, okay, we can only make, there are a couple of ways to do it, right? You can only make this transaction to sell. Is that true? Hang on, let me think about this. Yeah. So, yeah, I guess that's fine actually. So if K is, let me think about my off by ones. That's what I'm trying to think. You can sell. Because I think that's also what we talked about when we say defining the problem precisely. Because now we should think about how many, how precise our things are, right? Because in this case, that means that if K is equal to 0, we can actually return 0, because if there's no more transactions, we can just terminate early. So this is actually K is equal to 0, not K is equal to negative. That's where you have to be careful. Yeah, and if K is equal to 0, we return 0, then here, you can follow this through a little bit. That means that in this case, K has to be greater than 0 as part of the input. I know that technically you could put in negative, but that just would be weird. So, but yeah, so that means that K has to be greater than 0 in these states, and that means that all these K has to be greater than 0. So that means that because in this case K is greater than 0, that means that K minus 1 can be 0, but K will be greater than 0, right? So I think this is the correct state. Yeah, and here we started off by saying that, okay, in the beginning we have 2 transactions to complete. So here now let's run the code again. I think this should be correct, but of course we didn't do the memorization, which we should, but you know, and maybe something that I do talk about from time to time, but I do the analysis generated at the end, because that's just how I usually do it, but because it's easier to visualize it, I think, for the viewers at home. It's easier to visualize the analysis with the code in front of me, and I can explain why, like, okay, yeah, this is n squared or whatever, because I'm looking at each line of code, and this is why, you know, whatever. But what you should do, actually, is that you should do the analysis before you write the code as much as you can anyway. And sometimes you're wrong, sure, but you should do it, otherwise you're wasting time. Because if I'm doing some, like, for example, if I'm doing n cube, if I'm doing some n cube code and n is equal to 10 to the 5th, I don't have to write the code out to know that it's going to be too slow, because, you know, it's just too slow, right? So why are you wasting time writing code that is too slow? But that said, so you should do that at home, or you should do that also in an interview. You should do that before writing the code. But I am showing you that in a different order, because when I'm thinking about a problem in the beginning, I am analyzing it before writing it out, right? So yeah, so you should be doing what I'm doing now in the beginning, but yeah, let's think about the cases, right? I can go from 0 to n, so now we're thinking the number of possible inputs, where K is equal to from 0 to 2, right? So that means that this is O of n, this is O of 2, say. I mean, I know that this actually reduced to O of 1, but I just kind of want to illustrate it a little bit. So what's the total number of possible inputs is equal to O of n times O of 1, which is equal to O of n. And here, so how do you get the total work is equal to total time spent is equal to total, so number of possible inputs times work per input, right? I think that makes sense. You could even do the units, because work per input, of course, is just work over input, and of course the input cancels out, and that's what you get work, which is time spent. And of course that means that this is O of n times O of 1, because O of 1 is the work per input, because each line of here will take O of 1, because we assume that these functions will be O of 1 because we're caching it. So that means that this is O of 1 in general, and that means that this function is going to be O of 1 to call per input, and therefore total is going to be, as we said, the number of possible input is linear, O of n, and the work per input is O of 1, so that's this formula, which makes it O of n is equal to time complexity. And similarly, the space is going to be, so this is the number of possible input times O of 1 is equal to O of n is equal to space complexity. And this is, of course, if we write out the memorization. We haven't written out the memorization yet, so this is actually not true for the code that we have now. But yeah, but that's basically the idea, and I'm not going to do the same for cell. You can kind of do this. You could copy and paste, really, actually, I suppose. So if you really want to think about it, this is the complexity for the cell one. Just search and replace what I said for by. But yeah, now we have to do what we did yesterday with the memorization. So yeah, so we have has by cache is equal to force times 2 for and in this case n plus 1 is good versus what we had yesterday because we only use plus 1 on the I index anyway, so this is going to be at most n plus 1, which is all of n. So yeah, so by cache n plus 1. And of course you do the same for cell as well. I'm a little bit lazy right now, so I'm going to just copy and paste, but you get the idea. And here we just go if has by cache of I and k, then we return by cache I and k. Hopefully I don't have any typos, but that's basically the idea. Right? Yeah. And then of course we do the same for cell. Hopefully, I'm not really talkative during this particular piece because we did it literally yesterday. So hopefully this makes sense. And of course, even yesterday I have the link to the dynamic programming progression. So what I would say about this particular part is that you can actually reduce this in space as well. And I actually now remember, I don't think I talked about this yesterday. There is a cleaner solution for sure, but for this particular variation in this problem, this will be good enough. There is a very funky linear one that I don't remember, but maybe that'll come up in the next couple of days and I have to think about it. Yeah. Oops. Did I have a typo? Oh, whoops, I did 2. I mean, technically this is true in that the only possible values are 1 and 2. Like we can do maybe -1 here, but I like to just use the space because otherwise sometimes it gets a little bit confusing. Use your own discretion at home. But that is a bad off by 1, and that's why you run tests. But yeah, and now let's just create a very long array just for fun. Okay, I mean that looks long enough. Let's see if that's fast enough. If not, then I have a typo somewhere. Yeah, that looks good. What is the answer to that one? Only 10? Huh. Can't make that much money, I suppose. It's actually, oh yeah, because you want to make 2 transactions. Okay, but yeah, okay, let's give it a submit and hope it's good. Oh, and I did it last year too. Oh no, watch me mess up this time. The judging is taking a long time. Okay, wow. My code is way slower than last year's. Did they add more test cases? Because that is not even that much. I mean, it's a lot slower, not just a little bit slower. Wonder why that is. Let's see. Let me take a look at last year's anyway. No, I mean I did the same thing except for I use LRU cache and maybe you should check out that video. Actually, I'm too lazy to do it here, but you can actually do. I think I did it this way to be more like for teaching reasons. And maybe this is more understandable, and you can play around with this solution as well. So yeah, check out my video from last year. I probably have a video, and I'll send a link below. So definitely check that out, and let me know what you think. The complexity is the same, though. I think they just add more test cases. I don't think what I have here will be too slow unless I have a typo. Let's see. Let me take a quick look. No, I don't think I do anything that funky. All you cache should not be that much faster. Yeah, I mean, I think they just added a lot of test cases, which is kind of odd, maybe. Anyway, that's all I have for this one. Let me know. I'll put the links below on both the dynamic programming progression and when I solved it last year, because I like this solution as well. It just depends on how I feel about which one to teach, I guess. So yeah, I think this one is a good one as well for teaching. So I'll send a link below if you don't want to search. But that's all I have. Let me know what you think and try absorbing this as much as you can. Well, there are variations of this already next. So let me know what you think. Anyway, stay good, stay healthy. To a great weekend. I'll see you soon. And yeah, bye bye.